All right, should be live, and actually I kind of started a little bit too soon. Let me just check the audio to make sure that's working. Oh, interesting. Okay. Yeah, audio should be fine. Yep, audio's fine. My phone sends me about the chat over here. My phone sends me alerts if I actually I shouldn't do that yet. Hold on a second. Let me move the chat to a different spot. Just give me one moment. My phone will send me alerts when I am there we go. Okay. So this is gonna be the distribute coins and binary tree. My phone will send me alerts when I'm streaming, which is odd, but it does that. Yeah, so I think I got the chat. Okay. It's a weird thing, but it does that. Okay, you were given the root of a binary tree with n nodes, where each node in the tree has node.val coins. There are n coins in total throughout the whole tree. In one move, we may choose two adjacent nodes and move one coin from one node to another. A move may be from parent to child or from child to parent. Return the minimum number of moves required to make every node have exactly one coin. Oh, you can move from parent to child or child to parent. Okay. Oh, whoa. One coin from one node to another. Oh, man. The root of the tree, we may move one coin to its left child and one coin to its right child. Here we move one and move two. Oh, man. Whoa. Well, this is an interesting question. 100 nodes. Sum of all the node values is n. That's a really interesting question. Let me think about it. I don't actually know the answer. I don't think this is too hard though. It says a very high success rate, so I'm thinking maybe it's just not that hard. A lot of upvotes. People really like this one, huh? Excuse me. Well, I think you basically want to move the coins to their closest neighbors, right? And that's a good question. This is a good question. Well, okay, what's the distance to the nearest node that has a coin for each node that doesn't have a coin? That's maybe the one thing to question ask. I could try to do a breadth first search, a level order traversal from every node that has a. So I guess one thing is I would want to give every node an edge back to its parent, right? And then make it more like a graph traversal. And then what I'd want to do is have a level order traversal of the coins from each node that has coins, and basically distribute the coins in that way. Yeah, and if I just keep track of the movements, right? So like if I start from the one that has a 3 and I go to the next level, well, I guess I have all of the coins initially, right? I have all of the coins as one big sum, and then every 0 that I encounter, I would remove a coin and leave it there, right? And since all of these levels Yeah, I guess I could do it that way. That's kind of interesting. It's an interesting way of doing things. I like that idea. I like using a level order traversal. Let me just create an adjacency. Turn this into a graph. Turn this into a graph algorithm. I think is the way to go. I like that a lot. So let's do it this way. Let's do a BFS or a DFS first, and it's just going to be DFS root DFS int n is 0. Tree node root. And we're going to say root left, root right, increment n, and also have parent. Want to say parent dot pushback. Parent of this left value is n. That's confusing. No. Let's start with -1. We're going to increment n. And so the left node is going to be okay. This is a good question, huh? I'm not sure about this actually. Current value. We're going to say value dot pushback. You know what's better? Let's do it this way. This is a lot better. Okay. Parent's going to be -1. Let's say parent pushback ix, and then value pushback is root if not root val, and then we go left and right, and we say ix plus 1, ix plus 2. No, actually it's going to be ix times 1 probably should just return the index. This is going to definitely be ix plus 1, and then this is going to be the left index plus 1, and this is going to be the right index plus right index. That's confusing. The parent is this index. The current index should actually be ix plus 1, and that becomes the parent on the left for the left side. And the left side returns something, and then on the right side we're going to use that left index to figure out what the parent of the. So no, actually the parent is the same on the right side. Oh, that's confusing. They both have the same parent. That is very confusing. I need to number all these nodes, man. What okay, forget depth first search. That's too confusing. Too confusing. DFS, level over traversal, or BFS. Level is root, so it's going to be tree node pointer root. Basically while level is not empty. We're going to say for each, well, oh yeah. Yeah, okay, while level is not empty. Standard vector tree node pointer next level. Level equals standard move next level. For each const auto reference t and level, we're going to say if t left and if t right. We're going to assign indices or just value. Yeah. I realize this gets kind of confusing. Maybe I just have an adjacency matrix, actually, just outright. Values and adjacencies, right? Just do it that way. So index starts off at 0. For each value t, we increment the index. Say vals, push back. Not root, but t value. And then we say adjacency matrix, push back. It's a little confusing. So on the left side of it exists, we're going to say there's adjacency matrix of, this is for the parent, right? And now we say adjacency matrix of ix push back, or really parent it should be. This is so confusing. Oh my goodness. I'm definitely not doing this. I'm trying to avoid using a hash map. Like I could just hash indices to the. Part of me just wants to outright hash indices to the nodes directly and make this really simple, but I think there's a better way to do it. I just kind of struggling a little bit here. The root node is just index 0, right? The problem here is, I think this is fine. I think it's just parent plus 1. This doesn't make sense. That's not the value this index is going to get when it gets pushed. Maybe I could decide these indices here. I don't know. It's confusing. No. Well, gee. Huh. Well, this is very awkward. Okay, we could do it this way. We could do it this way. Next index is going to be whatever index is plus level.size, something like that. So this set of indices is going to loop through this level, right? The next set of indices, though, well, maybe it's the other way around. Let's do it this way. Let's do index is 0. And we add level.size as the next index. And then we can say increment index and increment next index a few times. So we're going to push into values, t value. We're going to push in this adjacency matrix to reach the children. And then we're going to have two things in the adjacency matrix. We're going to say, oh boy. I guess to do the whole level first and add all of the adjacency values to it. And then now we do each of those children, we now push back. And we say adjacency of that child. Something like that. This is very confusing. This is going to be next index, increment next index. Push back this parent, which is just ix. basically do the same thing. Yeah. And then also, this is really just step back, quite frankly. Don't even, oh, the reason we need this next index is I need to do the other way around. Yeah, that gets so confusing. This is not as easy as I thought it was going to be. I didn't think this was going to be that hard. Yeah. Huh. Okay. This is like really complicated. I don't know how to make this easier. That'll give me the adjacency matrix anyway, at least. Dang. So actually, I don't need this, by the way. I just need one for the initial row. Also, these get added to the next level too. This feels wrong. Feels like it's not. It's like not simple enough. Feels like this should be easier. So you could do a level order, something of a level order traversal to create a graph with back edges, right? Adjacency matrix and values. And then now I can do this like a basic graphing algorithm. So I can go for the start points also. Start points are going to be if t-val is greater than 0. So say start points dot push back this index. These are also the indices that are of interest. Okay. Very interesting, indeed. So anyway, it's quite a thing. Now this becomes still a tree, but undirected tree, and I can now make use of the adjacency matrix. So now I want to do another level order traversal again, believe it or not. 2. That is going to be start points int count result. Now we can do a while. Level's not empty. Again, next level. I think in both cases too, I should do next level dot reserve level dot size way. Okay, another loop. So the way this is going to work now is I have a double loop for the adjacency matrix. I have a visited array as well, which we're going to take the adjacency matrix, that size. We're going to say for each start point, so first things first, vd of x equals true. And then for each y, so if not vd of y, we're going to set vd of y to true. And then we're going to say if vals of y is less than or equal to 0, then we're going to increment vals of y. And we're also going to increment the count, or not the result. The result plus equals the count. And the first iteration is at 0, yeah, should be at 0. Actually, it should start with a 1, I think. And the next iteration, increment the count. This is a little bit confusing, but basically what's going on is first thing I do is create a adjacency matrix, a bidirectional graph out of this tree, and just create an adjacency matrix to do that. Simultaneously, I also figure out the values at each index as well, at each node, as well as figure out the start points, which indices are the starting points. That'll be my first level. Those are the ones that have coins in them. That'll be my first level. Take all those starting points and then start the count at 1, result at 0, and mark, loop through these levels, loop through the level and loop through the neighbors of that level, mark each of the values that are reached at that level as true, as visited, and then for all the neighbors that have not been visited. So this actually is a mistake. This is a mistake. I don't need that. I need to do it this way. Yeah, I need to do that first. So mark everything in the starting point as visited already. Now we can loop through the level, set up a next level, take a look at look at all the neighbors of that level that haven't been visited yet. If they haven't been visited, mark them as visited. And if their values are less than or equal to 0, which they should be, which actually is kind of the same thing as visited. I don't actually know if I really need this, quite frankly. I don't really need this, do I? Yeah, this actually is kind of handled inherently here. The only ones that haven't been visited are ones that are less than or equal to 0. So as soon as I increment those, I don't actually need all that extra stuff. I don't know if I even need this then. Yeah, now you just increment the count and update the level to the next level. Excuse me, the count is basically the amount of distance to the nearest value that has a coin. This is not quite correct. I thought this was correct, but this is not right. The problem here is, oh, no. Oh, no. Oh, gee. Shoot. Uh-oh. Hmm. Uh-oh. I think I need to do multiple level orders simultaneously. Oh, that's a mistake, huh? Uh-oh. Uh-oh. Oh. Oh no. Oh, that's very awkward. So there's multiple levels. This is going to be interesting. A little more sophisticated, a little more involved. The levels, actually. Each start point has another level. Uh-oh. Uh-oh. Let's just say loop is true. This gets a lot more confusing, huh? Well, loop is true. We're going to look at each level in the levels. Current level and levels. And we're just going to have start points, actually. It's going to be for each start point. Okay, so each start point is going to have its own level, basically. Is that right? Okay. Yeah, I'll make that in. This is quite a bit more complicated than I thought it was going to be. I think it's still okay, but it's definitely more involved. All right, so it's going to be levels dot of I dot pushback start points of I. All right. So each of these levels, each start point is going to get its own level, right? We're going to run all these level order traversals simultaneously, but they're all going to know which point it came from. And we're going to say the levels of I, pushback, start points of I. It's confusing about this. I'm trying to think, how can I, hold on, this, basically I want to remove start points. I think it's okay to do this. No, this shouldn't be start points. This should be this should actually be vals that size. Gets confusing, but yeah, that's what n should be. And then it should be reach start point. Push that back. Yeah, that's confusing, I realize, but that's what I want. That's actually what I should do. I'll explain why I'd want to do it this way. So now I can just go through what's in the start points. Let's start at the back. Let's do it this way. Start points size -1, I is greater than 0, decrement I. Okay. Oh, this is so much more involved. Now I can say start points is not empty. Might get an idea of what I'm looking to do. Whoops. Okay, now start points of I is x. Now I can say for each level in levels, current level in levels of x. So at each start point, we're going to run a routine very similar to this. Loops upon loops upon loops over here. So the next level is now current level. We look at for each constant, we'll say alpha and beta of this current level. There's this beta of alpha adjacent of alpha. We'll look at values of beta. Okay, this is oh boy. Okay. Oh man. Now here's where things get interesting. So for each starting point, we're going to do one iteration. We're going to get the current level for that starting point. We're going to do one iteration of that level, right? And we're going to say if vals of beta is less than or equal to 0 and vals of the starting point, which is x, is greater than or equal to 1, or is greater than 0, then we decrement vals of beta and decrement vals of x and increment the count. Then we update this next level and increment this count. Now the count actually doesn't get incremented here, it gets incremented here, by the way. Yeah, after the full iteration, the count gets updated. Current level just gets updated once here. The next thing that's interesting is if vals of x is less than or equal to 0, now I want to remove the start point. So I want to swap and pop. I want to swap start points of I with start points back. -1 or just back, yeah. Swap and pop. And so this will finish what it was doing. It doesn't reference start points at any point again. Finish what it's doing. It shouldn't really do anything anymore after that. Once vals is greater than or equal to 0, you could basically Once vals of x is less than or equal to 0, then you can just break both of these. Yeah, you just break. I mean, this will get branch predicted, right? This should be fine. You kind of want to break both of these loops, but theory it'll branch predict for the rest, hopefully. Now that's it. Now we should have what I want. Confusing, very confusing, I realize. But it's basically what I want to do. Holy. 41, oh boy. Levels, no. Not, oh. Uh-oh. Oh. I don't know. Is that what I need to do? All right. Did I do this wrong? It's just 3 loops. 1, 2, 3. No, it's, yeah, 1 extra loop. 4 loops, really. It's 1, 2, 3, 4 loops with some if statements. Gets pretty involved, huh? Oh. Getting confused. So much thinking I gotta do here. How many pieces to this TLE? No. Where's the TLE? Probably TLE's over here, by the way. It's probably this one, that TLE's. Let me see. Oh, this is so complicated. It's probably not the right, not the best answer. Though it's not this one, no. Oh, it's TLE over here. Huh. Really? Gee. Hmm. It shouldn't. I don't know why is that. Why is that happening? Value in the current level. We've got the neighbor. Adjacencies of the neighbor is less than or equal to 0. Then we're going to increment that value. X. Oh, I see what's happening. Okay. I see the problem. Oh, that's very awkward. I didn't even think about that. Yeah, you can run it because I'm removing coins from the. Oh my goodness. Okay. Never mind. We do want to have it, keep it simple and do it this way. Also, that's confusing. Oh, that is very confusing. Yeah, so one of the issues is that you could end up going back and forth I think you could end up in a loop where you're putting coins back and forth. It's not supposed to be doing that. No! What is going on? Really? Ah, what? Oh my goodness. Why is it tealing? Actually, you should do X, I think. And then also, vowels of X? What are we doing? 46 minutes. It's taking a while. What is going on? 3, 1, 1, 0, 1. Just keeps going endlessly, huh? This actually has to be, every node has to have one coin. Oh, that might be another issue here. Oh, okay. Oh man. That might be part of the problem here. I didn't think about that either. Shoot. Might have something to do with it. Oh, it's DLE, huh? Why is it doing this? What? Why? What is happening? X is 0. Oh my goodness. Something's going wrong here. It could be that just the first part of the code has some typo. Excuse me. All right. Oh man, can't type fast enough. I think the first part of the code has an error. This is like very unusual code to write, for me anyway. So X is 0. Start point size is 1. And then it's X is 1, start point size is 1. How? What is going on here? How is this even possible? What is happening? How do I get different values of X? Huh? What the heck? What is going on? I'm missing something important. It's gotta be some kind of implementation error or something like that I don't realize I'm doing wrong. Also, it's taking me a really, really long time. I think it's, well, anyway. Nope, I is 0. It's just not working. Of course. Excuse me. X is 3. I is 0. X suddenly becomes 1. What? How does X become 1? When did that happen? What is going on? What? Huh? When does that happen? Why did that happen? What? What is going on? When did x become 1? How did that happen? Huh? What the heck is going on? Swap and pop. I don't understand. Does this get called? Oh, this is very confusing. I don't know. I don't understand what's happening. Totally lost. Not lost, but just like I don't know. I'm missing the information here. Missing something important. I is 0, x is 0, x is 0, I is 0. Somehow x is 1 call at 7:30. Oh, okay. Hold on. Wait a second. Does not do what I think it does. Maybe that's the issue. That could very well be the problem. This just doesn't do what I think it does. Even though I swapped and popped, there's still a value there. Still something there, man. What's going on? I is 0. Oh no. 7:30. Start points is 0. Okay. So confused. What is happening? Like this loop should basically break after this. And then like how does x get what is I don't understand. What is going on? Why is this happening? Huh? Isn't this empty at this point? What is going on? How could it be? I'm so confused. Huh? Am I missing something? Shouldn't it just stop right there? Like, shouldn't that's, I don't, oh man. How bizarre is this? What is going on? What? The start point size is 0. And then, what is happening? How is it not empty? What? What? What is going on? Huh? What? No, that doesn't make any sense. Oh man. Well, that's confusing. That's really confusing. What is going on, man? What is happening? Okay, something really weird's going on here. Definitely missed something very important. It's empty. Jaw dropping, right? While it's not empty, we can keep going. But now that it's empty, it has to stop. What is going on? Oh, that doesn't make any sense. How? What do you mean it's looping infinitely? No. That doesn't make any sense. Huh. Is there another loop that's happening here? Is there something I'm missing? Oh no. What is happening? Why is it doing this? What is going on? What am I missing? I'm missing something important. Hmm. Oh boy. I don't know, man. All right, let's see. Gee. What is happening? 0.0. There's just a 1 in there. Where the heck did this 1 come from? What do you mean there's a 1 in there? What is happening? I don't understand. How is this possible? What is going on? What is happening? Why would this happen? What? Oh my goodness. This is absolutely bizarre. I don't know what's happening. Something so strange is going on here. I don't know what it is. Somehow it's empty at this point in time, and then all of a sudden it's not empty anymore. Huh? Is it getting optimized? Is that what it is? Some optimization code? It's messing with it? I don't know what's going on, but it's very, very strange. Very, very strange. What do you mean? What do you mean? I popped it here. How is it even? How is this possible? Oh, I just need to take a moment here and just. What? 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 Uh, oh, I think I know what the problem is. By the way, I know what the issue is. I can't use this. Maybe I do know what the problem is, but still confusing either way. No, I have to visit things more than once actually. Um, Actually, it's a mistake anyway. Um, um, I gotta think about this. Next level needs to push beta no matter what. So if values of x is less than or equal to 1, then we break. Otherwise, push. We push beta. We decrement. Decrement x. Increment vals beta. Increment the result. And then if our value of x dropped to less than or equal to 1, then we want to do these things and break, I think. Very, very confusing, I have to say. Oh, now it works fine, of course. Okay. Oh, I see. I think I understand what was happening. Yeah, it was just, okay. I think I was swapping and pop. Oh, all right, that must be it. Yeah, I didn't realize what I was doing. Okay. So confusing. Yeah, I've made that mistake before of like when you retraverse areas, you don't realize you need to retraverse an area. Let's get some more complicated test cases. Let's do like 20 things, like 50 and 1, 2, 3, 4, 5, 6, 7. Just throw a bunch of zeros all over the place. Let's make this like a 4, 0, 0, 0, 0, 0, 3, 2, 0, 3. All right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 11, 9, 6, 4. I think that works. Let's try that. Oh man, talk about a complicated solution. Gee. No. Oh. Oh. You gotta be kidding me. No. 1, 2, 3, 4. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 4, 6, 9, 11, 12, 15. Okay. So that's awkward, huh? Just throw some null values in there. All right. Fifth still 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 7, 5, 3, 2, 1. Okay. Whoops. And we'll just remove some things again. Yeah, let's get some weird pictures going on here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 9, 7, 4, 2, 1, 1. So this is TLEs in this case, huh? Of course it does. No, say it ain't so. Say it ain't so. Why? Say it ain't so. Exactly, n coins in test case 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 4, 6, 8, 9. Oh. How about that? I think I needed one more coin. Didn't count that properly. Oh. Yeah, so some questions I can solve in 5 minutes. Some questions takes me hours. Okay. 400. All right, so it's looping infinitely at this spot. This is on test case 3, I believe. Okay, well, that shouldn't be happening, quite frankly. Excuse me. All right, we'll just print the start points. Start points and the values. Um, that way. What is going on? Why is this so hard? This is like so much harder than it needs to be. The concept is very straightforward, but the implementation seems to be a little bit beyond me here. Not beyond me, but just not too hard for me to implement for some reason or another. All right. So 0, 3, 1, 3, 1, 2. So this is not correct initially, very least, and then you end up with 8, 1 for some reason. That should be done. 8, 1. How did this happen? How do you add more start points? What? That's okay. It should be 1, 2, 3, 4, 5, 6 start points initially. And it should be, what are the start points? It should be greater than 1, actually. Should be the start points. Yeah. That might be the problem, actually. Might be that simple. Okay. 0, 4, 2, 2, 4, 3, 7, 2, 11, 3. Okay, good. Good. Wrong answer. But at least it's not TLE. At least it's not TLE. Oh, okay, I see. This is interesting. So actually, oh no, my algorithm is not right. Oh no. No. Oh. I don't know what the problem is. No, wait. It should be fine. I was gonna say, I think the problem is that when there's already a coin there, I can move that coin somewhere else and then move another coin to that spot. But actually, that's not better. So never mind. That doesn't matter. My algorithm is just wrong for some reason. Why is it wrong? Okay, so that was I don't know what the printout I had before was. That was really odd. It just wasn't printing what it was supposed to print. But whatever, it's correct now. At least the starting points are correct now. But the question is, if I throw a 1 in there, it causes problems. If I threw a 1 in there, it causes problems. But why am I getting the wrong answer though? Shouldn't this be, so I got 16, should be 14. This goes 1 here. We have 1, 1, 2, 1, 1. So 1, 2, 3, 4. 5. I don't know. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Oh. And the way I did it, I put 1. Oh. Oh no. Oh no. Oh, that's really awkward. I I should have put the 3 here and here. Instead, I put a 2 here and the 3 here and all the way over here, which is why I got 2 extra. Instead of going, I could go 1, 1, 2, and this could be 1, and this could be 1, 2, 3, 1, 2, 3. But instead, I did 1, 1, 2, 3, 1, 2 instead of 1. Yeah, this could have been 1 and 1, but instead I got. That's very awkward. All right, my solution is not right. My solution is not right. The idea is logically wrong. Has a considerable logical error there. Oh, of course it does. No. Oh, well, gee. Okay, of course. Of course. Oh. Excuse me. Yeah, I guess I needed to really think that all the way through, huh? Huh. How does that work? How do I fix that? Well, gee. Well, gee. I don't know. Um, I'm not really sure what to do about this, actually. Uh, huh. Excuse me. I'm wondering if I should just use a modified version of the DFS. Yeah, this idea wasn't really good because yeah, I don't place the coins in the right spots. I don't know. Um, well, gee, I don't know. I don't know. I don't know. Uh, this is a good question. Um, I'm trying to do it in linear time. I realize that maybe that's why it's taking so long. Probably could do this in quadratic time and it would be a lot faster. I think that's the case. Yeah, I think if I did this in linear time, it probably would be easier. Well, I don't really know actually. That's actually a good question. I have no idea. I don't know how I would do this in quadratic time as well. I have some guesses, but I don't actually know. Or yeah, no, I don't actually have very many ideas even in that regard. Um, I don't know. Hmm. Maybe I should actually. Oh, what if I just sort the coins by the largest amount first? Ah, I like that better. That's what I should do. Aha! I should have done a level or a traversal with the largest coins first. That's definitely what I should have done. Okay, I did this wrong. I did this wrong. Let me try it a slightly different way. I think I figured out what's wrong though. Okay, let's do this. index 1, index 2. We want to say compare vals of index 1, vals of index 2. Okay. I'll come back to that. Oh no, that's what I want. Also, we're going to do a full level order traversal on each start point. And we're going to say we don't need levels anymore, actually. We don't need this VD anymore either. And we just want to go each value of x and start points. Starts off with level as x. Call that current level. While current level is not empty. Can do these things. Okay. Whoa. Okay. I don't know what did I do? All right. We're gonna sort in the other direction. Sort in the other direction. Count at 0, next level, current level, it's not empty, alpha, beta. Okay. Sure. Oh, I think this has to do here. Okay. This is a little confusing, I realize. We don't need to do all this swapping. Okay. I think we just need to do the one that has the most coins first. I think that's all I need to do. No. If I do that, then I end up with 1, 2, 1, 1, 2. No, that's not right at all. No. 1, 2, 1, 2. This should go 1, 1, 2, 1, 1, 2, 3, 1, 2, 3. Yeah, that's not correct. I don't know. I don't know. I gotta go lay down. It's one of the things I kind of dread about these questions. Sometimes I get something I'm not familiar with at all. I don't know the answer. I've got to just sit there like a doofus for hours on end wondering. Oh, as it turns out, all these questions, these are from computer science algorithms textbooks, and they're very. You're basically just supposed to memorize this stuff. You know, you're not really supposed to. You're not really supposed to try to figure this stuff out on your own. Quite frankly, it'll take you a lifetime, which it has taken me a very, very, very long time. I'm out here reinventing algorithms that people already figured out. It's kind of absurd. It's a little ridiculous. It's true. Yeah, it's the only thing you would do if you like wanted to be an academic. Maybe you could do something like that. But I guess it does train your brain to think a little bit, which is not the worst thing. You know, think up new stuff. So it's not terrible, but it is like really annoying. So it's really annoying. It takes so much time. I don't know the answer to this question. I just don't know. Gee. Well, um, huh. What happens in the case of a tie? Right? That's kind of the problem that I'm facing here is like, what do I do in the case of a tie? By hand, I could see where things should go, but what's the algorithm that I'm using to figure that out? It looks like I should do the yeah, I don't really know actually. I don't know. Um, which coin do I move first? Let's start with that. Um, I think what I want to do is I want to find out for each position what its nearest neighbor is. I think that's what I should be doing. For each position, find out what its nearest neighbor is. Um, and maybe I should use a heap. Yeah, that might be the way to go. Because some spots have more than one nearest neighbor. However, other spots don't have nearest more than one nearest neighbor. And those other spots should take that one nearest, exhaust that one nearest neighbor as much as they can. Um, yeah, I think that might be the way to go, actually. Um, is to take all the nodes that only have one nearest neighbor and move the coin to those spots first. Move the coins to those spots. And then the nearest neighbors get updated because now potentially you've removed some coins, and now you don't have a source of coins that's in that area. This is kind of like a logistical algorithm type of a thing. It's a pretty interesting question. I don't have the answer immediately. I think maybe it's a good spot to stop and take a break. Maybe make this a part one. But yeah, I think something along those lines, like something that can some kind of data structure or some kind of algorithm that would keep track of. Now, again, I could probably do this in quadratic time, right? For each coin, figure out which coin should be moved and where it should be moved to, and just process the whole tree every time. Excuse me, process the whole tree for every coin. um, yeah, I don't know if that's a good idea. You could definitely find the for each node. I can run like a level order traversal to figure out what the closest coin reserves are. I mean, is there a faster way to do that? That might be it. I don't know. Well, if I find the coin reserves, the closest ones, let's say I do that, and um, if there are ties, right? So each node is going to have, a closest value, and if there are ties, then I would write both elements in there. Now, what's interesting is I might want to keep a count, or not even a count, but a list. Organize the nodes by their closest reserve. And then what happens is when I exhaust a reserve, then some of those nodes don't have a closest node anymore. Well, that would be interesting. Huh. Okay, well, you could do a quadratic time algorithm where you just assign to each node sort of the order of the reserves. And then process all of the nodes that have a single closest reserve, right? And once you've processed that, then whatever reserves are left, you might remove them or not. Once you've done that, it doesn't matter which reserves you use, sort of. That doesn't matter, but you can just use the smallest reserves then. Yeah, so you want to use the closest possible reserves basically at all times and start with the nodes that have the fewest reserves possible, fewest closest reserves. And yeah, if you do it that way, then I believe you could do this in quadratic time. It's a little bit complicated, but it can be done. Oh. I don't really like this idea. I don't really like this idea. Huh. It's kind of like a topological sort type of a thing where it reminds me of like a topological type of a thing where you're looking for the nodes that only has like one nearby reserve. And then once you've exhausted that reserve, then there are other nodes that only have one nearest reserve. Very interesting question, I have to say. Pretty interesting question. I think maybe you can do this in linear time if you just I'm not sure actually. You know what? Actually, maybe you could do this with just a DFS. I think what you've got to do is you've got to figure out for a given subtree how many coins is in that subtree. If there are more coins in the subtree than there are nodes in the subtree, then coins need to come out of that subtree. If there are fewer coins in that subtree and more coins in the left subtree and root, right, or the rest of the tree, then coins need to go into that subtree. Maybe that's the way to think about it. And you've got to figure out whatever the cost is to get those coins over there from the left subtree to the right subtree. Yeah, I don't know. Excuse me, that might be the better way to do this. It doesn't necessarily need to be a graph question. Although the analog for this question to a graph is definitely interesting too. I think these are technically called flow problems. I don't really know. Yeah, let's say there's more coins on the left subtree, and they need to be added to the right subtree. First things first, you can distribute coins directly from the root into the right subtree. That's number one. Number two, the coins that are yeah, I think you would actually because you would need to take, depending on which subtree has more coins in it, you would need to spend some cost to get the coins to the root from the left subtree if you need more, and then you need to spend some cost to move the coins into the right subtree from the root. And interesting. And then in the left subtree, now you have a certain number of coins that need to get up to the root, and so you've got to figure out what that cost is, as well as the same routine, the number of coins that need to get to the left side and the number of coins that need to get to the right side. I think you can use a DFS to do this, and I don't think it's that hard. Yeah, I think you could use a clever DFS. Maybe it's not that hard. Maybe I don't know. It's maybe it is hard, but I don't realize it. Interesting. I think I want to take a break here. I think I want to ponder this a little bit more and come back to it later. I like that idea though of using like a clever DFS, basically figuring out there's a certain amount on the left side, certain amount on the right side, certain number of nodes, and a certain number of coins that you have in each subtree. Excuse me. And it's not too hard to figure out. To run one iteration to figure out, and maybe you just use a simple hash map, hashed each tree node address what the number of coins are in that subtree. That's not too hard to figure out. And then you can do another DFS after that once you have those numbers to figure out how much need to be moved from one to the other to calculate how much moving needs to happen. Gee, all right, I think I'm going to stop here. Yeah, I think Interesting. Good question. Definitely a good question. I think it can be done in linear time. A really high acceptance rate. I feel like this is a little bit harder than I thought. I think I underestimated or overestimated something here. I thought this was going to be really quick, but no, especially with such a high acceptance rate. I think some people have suggested that when there's a very high acceptance rate, it's because the editorial is open. It's a hard question, and people just basically copy paste the editorial. And that's it. I don't know. Maybe this is easier than I realized. I could be wrong. But yeah. All right. I'm going to make this a part 1 and stop here and take a break. Probably go to bed. Spent quite a bit more time on this one than I thought I would. So yeah, thanks for watching. Talk to you soon. Like the video if you like it, and don't forget to follow as well. Yeah, hail victory, and I don't know what I'm gonna do. Just take a break. Well, I do know what I'm gonna do. Yeah, take a break and figure out what to do from here. Maybe make more food. I don't know. I don't know what I'm gonna do. I don't know. So yeah, take care.